what we're going to do is define the circular function. And in order to do that, we need to deal with our unit circle. So our unit circle, remember our form is, x minus h squared plus y minus k squared equals the radius squared. Well, the radius we want to use is radius 1. And as you can see here, if I went to any point on this circle, the radius would be a distance of 1. Okay? And the center's at 0, 0. So we got these points, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And we want to pay attention to the angles of our circle and how that relates to the coordinates. And in order to do that, we need to have a basic understanding of what's occurring here. So we're going to base everything off the positive x-axis. Okay, that's going to be our start. So if you look at this frog here, for example, what would the coordinates of the frog be after the wheel rotates 90 degrees? So if this frog rotated on the wheel 90 degrees, he would be where? At this point right here, 0, 1. Okay, if he went 180 degrees from the start, where would he be at? Well, 180 would get us right here, so negative 1, 0. Well, how far would the wheel rotate for him to end up at 0, negative 1? What if he wanted to get all the way down to this point? He'd go another 90 from there to be at 270 degrees, so 270. And what about this? Where would the frog be after 630 degrees? Well, a circle's only how many degrees? 360, right? So after he goes 360, he's back to the start. So what I might want to do is take away as many 360s from 630 as I can. Well, how many times does 360 go into 630? Just one. So I'm just going to subtract one of those. And I have 270. So really, he traveled 360, got back to the start, and then he went 270, which would put him at 0, negative 1. So traveling 630 degrees is kind of the same thing as traveling 270. You end up at the same spot. That's where we're really trying to get out of that. So just to quick fill out this table, this would be very useful for us. So at 0 degrees, we're at 1, 0. At 90 degrees, we're at 0, 1. At 180, we're at negative 1, 0. Where the opposite's the case, 0, negative 1 at 270, and then we're back to the start at 360. So those are kind of very important points. Because what we're going to end up finding out as we start looking at some triangles being drawn in here is that the cosine is going to relate to the x value, and the sine is going to relate to the y value. So for example, if I would type in the sine of 0, 0 degrees, I would get 0. If I typed in the cosine of 0, I would get 1, right? Because these are really the degrees. And if I look, the sine of 0 is 0, and the cosine of 0 is 1. And that'll make more sense in just a little bit, but just have a heads up that cosine goes with the x's and sine goes with the y's. Some other important places we need to know on the unit circle are where our special right triangles occur. So we're looking at our 45, 45, 90. And our 30, 60, 90 triangle. So let's pay attention to our 45, 45, 90 right away. So if you remember that one, the base sides, so opposite the 45 angles, we have x. And then to get the hypotenuse, we just multiply that side by root 2. So it's x, x, x root 2. And if we're talking about a unit circle, and I would draw in a triangle into my unit circle, we're saying like this is the center of my circle at 0, 0. And this point right here would be on the circle. So we're saying, the circle's coming up like this and like this. So really, this is the radius, which we're using 1. So if I look down here, here's our radius of the circle that we're going to imagine. And so if I wanted to find the side lengths of my 45, 45, 90, I'd have to divide by root 2 in order to find it, right? Because to get rid of this root 2 over here, I would divide it by root 2 to get to x. So I divide by root 2. Which is like this, which we can't have a radical in the denominator, so we'd multiply by root 2 over root 2, which gives us root 2 over 2, which these are the same thing, right? So then we need to know that. We need to know that those sides are root 2 over 2 for a 45, 45, 90. So let's kind of apply that here. So what are the angle measures at each point? So if I look at this first point here, if I drew in a right triangle halfway up this piece of the circle, that would be 45 degrees. Okay, so this is 45 degrees to this point. And what would the coordinates be of this? Well, we know that the radius is 1, and we just talked about that this would be root 2 over 2, and this would be root 2 over 2. So the coordinates of this point would be, well, the x value, which is root 2 over 2, this guy right here, and then also the y value would be the exact same thing, right? Root 2 over 2. So it'd be root 2 over 2, comma, root 2 over 2. That would be this coordinate. Well, if that's the case, if I go all the way over to this piece, if I drew in a triangle, it would be 45 degrees here. But technically, this angle is what? 135 degrees. So I'm going to put the angles with these coordinates. So this was at 45 degrees. So at 135 degrees, we had the coordinate. Well, what changes? Just the x value. The x value becomes negative. That's the only thing. So this would be negative root 2 over 2, comma, root 2 over 2. And then we go down. If I look in the third quadrant, both of these guys would be negative. So it'd be negative root 2 over 2, comma, negative root 2 over 2. And how many degrees would that be? Well, it's really, 45 from here onto 180. So that would be 225 degrees. And lastly, x value would be positive root 2 over 2 and negative root 2 over 2 for the y. And that would be how many degrees? Well, 45 onto 270 would give us 315 degrees. Okay, so those are important to know. What the points are, what the coordinates are at the specific degrees on our unit circle. And we can do the same thing for a 30, 60, 90. So if you remember a 30, 60, 90, x is always the 30 side, so opposite the 30. The side that's twice as big as the x is the hypotenuse. And for the 60 side, that's always x root 3, x times the square root of 3. So if I come down here, now we're imagining that this is our radius again. So the radius is going to be 1 on our unit circle. So in order to get to the 30 side, I would have to divide by 2, which we did. I got 1/2. And the easier way to do this is to think of, well, how do I get from the 30 side to the 60 side? Well, how did I do it over here? I multiplied by root 3. So 1/2 times root 3 is really root 3 over 2. So that would be the 60 side, root 3 over 2. Okay, so we need to know those things. Those are important that we memorize those. So let's look at those coordinates. So let's draw in our 30, 60, 90 here to this point. So we're saying that this is 30 degrees. So that would be 60 right here. So that means the 30 side, we said, was just what? 1/2. And the 60, because our radius is 1. So we take half of that to get to the 30 side. And the 60 side, is 1/2 times root 3, so it's really root 3 over 2. That would be this distance right here. So this coordinate would be the point root 3 over 2, comma, 1/2. And this is for what degree measure? 30 degrees, right? Okay, and we'll look at what 60 degrees looks like, but let's just all deal with these guys. So if I come over to this other coordinate over here, remember this would be 30 now. So what is that actual angle according to our positive x-axis? That would be 150. So this is at 150 degrees. And this would be the coordinate. Well, now basically, it's the negative of our root 3 over 2. So I'd have negative root 3 over 2 and positive 1/2. Okay, how about if I go down to the third quadrant? Well, I'm really adding 30 onto 180. So I'm at 210 degrees. So at 210, my coordinate is, now they're both negative. So I got negative root 3 over 2, comma 1/2. And the last one over here, this would be, well, now we have 30 subtracted from 360, so this would be 330 degrees. And that would be root 3 over 2, positive x direction, and negative 1/2. Okay, so hopefully you can see where I got those coordinates kind of based off that first one that I drew in. I'm trying to go through this quick, so you might have to pause and ask me about these things. But there we go. And then I would do the exact same thing right here. I'll look at the first one really quickly. So this would be 60 degrees. So it's just alternating where my 30 and 60 are at, which means this is 1/2, and this is root 3 over 2. So that means the coordinate at 60 degrees would be 1/2 root 3 over 2. And then guess what? I just use that coordinate the whole time, and I just switch what's negative. So here my x value is negative, and I'd have root 3 over 2. Down here, both of them are negative. And lastly over here, just the y value is negative. And what would the degrees of all these be? Well, the red guy up here, that would be, 30 degrees from 90, which is 120 degrees. And then down here, this would be, 30 from 270, subtracted from there, so that would be 240 degrees. And lastly, this would be 30 added on to 270, which is 300 degrees. So what we need to do is actually memorize these angle measures and coordinates. Wow, that seems hard. Okay, but I bet it's not too bad. So let's think about it. Let's just look at our first quadrant. Okay, so remember at 30 degrees, what's our coordinate? Well, the 60 side is the x in this case. So this would be root 3 over 2, comma, 1/2. Okay, and then the 60 degrees, what's different? Well, they just flip-flop, right? 1/2, comma, root 3 over 2. And in between at 45 degrees, this is the nice part because their coordinates all deal with what? Root 2 over 2, comma, root 2 over 2. And then how does that change as I go about? Well, once I go 30 degrees past my 90, I'm at 120. And what does that coordinate look like? Well, it should be very similar to which coordinate? This guy, right? Because they got the same kind of x and y, but they just switched negative values. So this one would be negative 1/2, root 3 over 2. This one would be, 45 degrees from there, which we said was at what? 135. And that's the coordinate. Well, now just the x value changes. Root 2 over 2, comma, root 2 over 2. And lastly, right here, remember, it should just be this guy, but just with a negative root 3 over 2. And what degree measure would that be at? Well, that was what? 30 from here again, so that was 150. So if you notice, the gap in between these is 15 degrees. That might be helpful as well. 15 degrees. And this was the coordinate negative root 3 over 2, 1/2. So I bet you could fill the rest of that out to help you out. I'd maybe have this whole thing in my notes. So I have a guide on all the different spots of the unit circle. Okay, another term that we're going to use is called the reference angle. And the reference angle is the acute angle. It's always acute, so that's important, made with the x-axis. So for example here, this is the angle measure 60 degrees, which also is the reference angle 60. Okay, they match because they're both from the positive x-axis. If I look at this one, now this was the angle measure 240, right? Because I went to 90, 180, and not quite to 270. So it's angle measure 240, but I'm just paying attention to the reference angle, which would be that piece right there. So from 180 to 240 is 60 degrees. That would really be 60 degrees right there. At 120 degrees from the start, so the angle measure of 120. Remember, if I look from the positive x-axis, that would be this piece right here. So that's actually 60 degrees, 180 minus 120. Okay, so the reference angle is just from the positive x-axis. And lastly, if I had one in the fourth quadrant, an angle measure of 300, that's really, 60 away from the positive x-axis. So that also has a reference angle of 60. So all those had a reference angle of 60 degrees, but they all were in different quadrants. They were all different angle measures overall. Another term we'll use is coterminal. That means they have the same terminal side. And a terminal side just means, the side that's away from the x-axis, that makes the angle. Okay, so this is the positive x-axis. The terminal side will be the side that makes the angle. So 50 degrees is coterminal with 410, right? Because if I subtracted 360 to get back to the start, I'm at 50 again. So these guys would be coterminal. We're also going to look at what we call periodic functions. So if the output values of the function repeat in a regular pattern, okay, they have to have a pattern, they're called periodic. And to find the period, what we do is we find the distance between x values before the graph repeats. So before it repeats. Okay, so if it's periodic, it's got to have a pattern. And I would take a look at the x values before it repeats. So to first tell if it's periodic, I check to see if it has a pattern. Well, it looks like the exact same pattern, right? And then I check the distance between. So does it have the same distance between? Yeah, it's 3. This is 3, 3 in between, 3 in between when it repeats, right? So it repeats every one of these dots, and the distance between is 3, and it has a pattern, so it's periodic, and we'd say the period is 3 because it has a distance of 3 in between. If I look at this one, they have the same distance between 2, 2, 2, 2, 2, but is it the same pattern? No. It goes up, about to 1 here. Now it goes up to 2. Now it goes up to 3. So the pattern is not the same. So pattern screws it up, so it's not periodic. And let's look at a little funkier one. Is this graph periodic? Well, let's look. Let's check how the pattern looks. So it goes up, comes down, and then back up. Goes up, down, back up, down, back up. Good. So I would say, yes, it's got a pattern. Now we got to check the distance between the period. Well, let's check it out. So from here to here, it's 2. And from here to here, it's also 2. And it's 2 everywhere else. So I would say yes. But is the period 2? No. Remember, it talks about when it repeats. When does this pattern start repeating? It starts here, goes up. It hasn't repeated yet. And then here is when it starts to repeat. So really, it takes a distance of 4 in order for it to repeat. So it's not 2. The period is 4, right? Because then it would go up and then down right there. Period of 4, right? From -2 to 2 is 4. So 4 is the period. Same thing right there. All right, and like I mentioned earlier, what we're going to look at is the cosine of the angle is defined to be the x-coordinate of the ordered pair. And just the opposite. The sine of the angle is going to be the y-coordinate of the ordered pair. And why that works is this. If I drew in a triangle and I threw in an angle, I just call the angle theta right here. We're saying this is angle theta. My x value is on the x-axis right here, and my y value is on the y-axis. So if I wanted to write something for the cosine of the angle, cosine would be, cosine of theta equals the adjacent, which is x, over the hypotenuse, which is 1. Which gives me x. So really, the cosine of the angle measure should equal to whatever that side length distance is. So this actual x-coordinate right here. And the opposite is the case for the cosine, right? Or for sine. Because sine is opposite, right, y. So sine of the angle is opposite, so y, over the hypotenuse, which is 1, which simplifies to y. So sine of the angle should equal the y-coordinate, or like the vertical height of that triangle. So how we can use that is this. And how it relates as I move into the different quadrants, it's going to be the exact same thing, except what really happens here. My x value is just technically, negative. It's just going to be negative. So if I were to type in the cosine of this angle, I should get a negative value when I do it. But so it's really going to be, a negative x rather than a positive x. So before we look further, if an angle is in standard position, that means it has one side on the positive x-axis, it's like this, and the other side is called the terminal side, which we already kind of made reference to. So for example, if I said 60 degrees and it's in standard position, that means, it's at the positive x-axis and it's moving up to the terminal side. All right, so for example, we just talked about how the cosine really equals the x value. So it's always the x value of the coordinate when I type the cosine of a degree. So for example here, the cosine of 0 would be 1. The cosine of 90 would be 0. The cosine of 180 would be -1. Cosine of 270 would be 0. And I could actually type these into my calculator and I should get the exact values just like that. Well, the sine's just the opposite. Now sine of 0 would be 0, right? Because it's the y value at 0 degrees. Remember, 0 degrees is the positive x-axis. And as I go up to 90, now my y value is 1. So sine goes with the y's. At 180, my y value is 0. And at 270, my y value is -1. So we need to memorize how those work. I mean, my calculator still give me that, but we got to get this memorized so it just comes off quick. What if we did something like this? At 45 degrees, what would the coordinates of the position be? Well, if we remember, what is this coordinate? This would be √2 over 2, comma, √2 over 2. So technically, at cosine 45 degrees, this would be the x value, so √2 over 2. And this would be the y value, so √2 over 2. And if I type the cosine of 45 in my calculator, I'd get a decimal. It's like 0.707, blah, 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 blah. If I typed in √2 over 2, I get the exact same thing. And this will work as we go along. So at 135, that would be, just remember my x value is now negative here at 135 degrees. What about at 30 degrees? Remember this coordinate would be √3 over 2, comma, 1/2. So when I type in cosine of 30, it's really √3 over 2. If I type in sine of 30, it's really 1/2.